Okay, so I'm sorry I can't be here on Friday. I got to be out of the classroom, so I wanted to give you guys something to go off of. Be sure you download the notes first before you start watching this. It'll be a lot easier for you. So I'm going to go through what I would normally go through if I was here that day. Okay, so we're talking about 2.5 inequalities. First, we're going to talk about the properties of inequalities, and remember these on the right-hand side here. Okay, don't forget these. Okay. You've got the symbol for greater than, the symbol for less than, the symbol for greater than or equal to, less than or equal to, and then there's not equal to. So you have all these 5 to remember. Okay, keep that in your mind. So the first property is you can multiply inequality by a positive number. So such as, 4 is less than 9. True statement. So if I take 3 times 4, it should still be less than 3 times 9. And yep, 12 is still less than 27. Whoa. Yikes. Yep, true. So that's the first property that we would have talked about. Second, you can multiply by a negative number, but of course there's always a catch with inequality. So let's see here. 4 is still less than 9. True. Now what if I was going to multiply by a negative number? So we'll multiply by negative 3. So negative 3 times 4 less than 9 times the negative 3. So negative 12, right, less than negative 27. Well, this is wrong, right? This is totally wrong because, of course, negative 12 is not less than negative 27. So what we have to do is we need to switch the direction of the sign to get negative 12 is now greater than negative 27. So whenever you multiply by a negative number, remember to reverse the direction of the inequality sign. Now, I'm sure you've heard that before, but you may not have also heard about when you are dividing by a negative number. So when you multiply or divide, you need to reverse the sign. Okay, multiplying or divide, you have to reverse the sign on an inequality. Let's talk about the reciprocal identity. First, if a is greater than 0, okay, then that means that 1 divided by a will also be greater than 0. So notice that this is the reciprocal of that, which is why it's called the reciprocal property, right? So if a is bigger than 0, then 1 over a is bigger than 0, right? So 1 is bigger than 0, right? 1's not a good one because the reciprocal is 1. How about 3? 3 is bigger than 0, right? So 1/3 is also bigger than 0. So that's what that is saying. And it also says this. If a is less than 0, then the reciprocal 1 over a will be less than 0. And again, right, we're still talking about this reciprocal here. So negative 2 is less than 0, right? Let's see here. On his examples, negative 2 is less than 0, and the reciprocal of negative 2 is negative 1/2, which is also less than 0. So all of this is exactly what that is saying over there. So the reciprocal identity, make sure you study that one. Okay, for graphing inequalities here, for part A, sometimes you will see this, okay? I'd like you to graph all x such that x is greater than 4. Now, what you're used to seeing back in the day when you're a kid is something that looks kind of like this, right? You'd have some hash marks here, and it looks something like that. And so we'd say this is 0, 1, 2, 3, and then 4. So since it was greater than, okay, you would normally have put an open dot, right? And you would have shaded to the right, and you would have said, oh, my answer is all this stuff to the right-hand side because it's strictly greater than 4. Okay, and then you'd use the open dot because you're saying you're not talking about the number 4 itself, you're talking about every number after the 4. So, all of that is going to be the same except one little thing. So for us in this class, what we're going to use, okay, we're going to have the same number line, just like this, okay, and with the same hash marks and everything. Okay, so 0, 1, 2, 3, 4, and 5. But for us, instead of this open dot right here, we are going to use a bracket, okay? So a bracket or a parenthesis, depending on what you want. So circles tell us that we have parentheses, and we're going to the right, and we're shading all of that stuff, okay? So a circle represents a parenthesis. If we were going to include the 4, we'd use a bracket. I'll give you an example of that in B, okay? So example B would be something like all x such that x is less than or equal to 5. So since we want less than or equal to 5, okay, we're going to use a bracket. You also don't need to give me all the numbers on the number line. Just do this. Give me 0, okay, and then give me 5 in the right spot. And what I mean by the right spot, meaning that 5 should be to the right of the 0. And now face your bracket, since it's less than or equal to, face your bracket, okay, to the left and draw your arrow, and this is everything that represents x less than or equal to 5. Okay, so again, parenthesis means open dot like you would normally do it, and a closed dot would be the bracket. So we're either using parentheses or brackets for that. Okay, so let's graph a combined inequality here for just a second, okay? Let's graph all x such that x is greater than 4, and, this is a key word, and x less than 6. So all x that's greater than or equal to 4 and less than 6. So all of this is a set that you are being asked to graph. So look, give me a number line. All right, give me a number line. Give me the points in question. So give me 0, give me 4, give me 6. Okay, all of that is good. So the first one, right, we want all x that are greater than 4. Now, since it's greater than, we're going to use a parenthesis, greater than 4. So I want everything that's shaded to the right. Now, I want all x that is less than 6. So again, parenthesis and shade everything to the left. And of course, you see that there is some overlap here, right? So the solution to the inequality is all the stuff that's in the middle. And whenever you have an and statement, you should have stuff in the middle. So let me explain then or inequality right now. Let's take that same example and let's do this. Let's do all x such that x is greater than 4 or x less than or equal to -1. So I'm going to change it slightly. Here we go. Draw my thing. So again, give me the 2 points that are in question here, okay? So let's put -1 on the map. Let's go 0 and then let's go 4. Okay, just those points. That's all you need. So we want everything that's greater than 4. So we're going to use a parenthesis and shade to the right because we want greater than 4. So we want everything over here. And we want less than or equal to -1. So I'm going to use a bracket and shade to the left. Now, because this is an or statement, I am allowed to have this. If this was an and statement, there'd be no solution because there's no number in the world that's bigger than 4 and less than -1 at the same time. But because this is an or statement, I am allowed, notice I have 2 things going, one to the right, going to the left. So 2 separate number lines working out for or statements. A single spot for the and statement is in the middle. Okay, so I'll set up a you try, so hopefully you can pause this and then try it on your own. So here's what you would get, right? Let me give you this one. Graph the set all x such that x is greater than 4 and x that's greater than 6. Okay, so go ahead and pause this and see if you can actually get the answer. Okay, and I'll work it for you right here. So let's see here. I'd have a 0, and then I'd have 4, and then of course I'd have 6. So did you get this right here? This should be parenthesis shaded to the right, everything. Okay, and then I'll use a green here. Parenthesis and shaded to the right. And since it says and, you are looking for all the numbers that make both statements true, and that only exists right here because it says and, right? So it has to be bigger than 4 and at the same time bigger than 6. Well, all that stuff is right here. Okay, so all of that needs to be shaded out. Let's try another one here. Let's try the set. Oh, here we go. All x such that x is greater than or equal to 4, or there's an or statement there. X is greater than or equal to 1. Okay, let's get my number line going. Here we go. Here's our number line. Let's go. Here's 0. Okay. Here is 1, and here is 4. So I'm being asked greater than or equal to 4, so I will use a bracket that's facing to the right, greater than or equal to 4, or greater than or equal to 1. So I'll use blue here, and I want greater than or equal to 1. And again, it's greater than. And the statement is saying it's or, so it can be either greater than or equal to 4 or greater than or equal to 1. So in this particular case, our solution is everything from the 1, including the 1, and shaded off to the right. So all of these are solutions on the number line that will satisfy that inequality. Okay, then the last part of the lesson is writing an inequality in interval notation, and then vice versa. So you are used to this. This is what you guys are used to. You're used to 1 less than or equal to x less than or equal to 3. Well, I need you to write that, since we're including the 1, a bracket 1, comma 3. So that's an interval notation. This is an inequality notation. If you had negative 4 is less than x, which is less than or equal to 0, you could have this. You would have a parenthesis on the negative 4, and you would have a bracket on the 0, because the bracket is being included because it says less than or equal to. If you have just straight up x is greater than 5, well, we're going to use a parenthesis on the 5, and we're going to go to positive infinity. And notice that I'm going this direction, right? So I have the 5 comes first, then infinity. I would not want to write this. I would not want to write infinity, comma 5. This is not the same thing as that, okay? And by the way, always, always, always use a parenthesis on infinity, because you can never actually get to infinity, so you cannot encapsulate infinity. That doesn't make any sense. Okay, so number 4, 5x is less than or equal to negative 1. So in this direction, I'm coming from negative infinity, yes, all the way up to negative 1, and I'm going to use a bracket because it says less than or equal to. Okay, so we need to go from inequality to interval notation. Make sure you look over that. And we need to go from interval to inequality notation. Let's go the other way, so we'll use a different color here. What if I give you this, okay, 1, comma 4 with a parenthesis? Well, that means that 1 is less than or equal to x, which is just strictly less than 4. So I'm going back to inequality. So you need to be able to go back and forth. How about this? How about 2, comma infinity? Well, that just means x is greater than 2. How about this? The closed interval from 2 to 3. Right? That's silly. That's a terrible bracket. Holy cow. Closed interval from 2 to 3 would be this. 2 less than or equal to x less than or equal to 3. Notice that x is right in between the 2 and the 3. So that's saying that you have all of the numbers that are between 2 and 3, including 2 and 3 themselves. And the last one here, negative infinity to negative 3 with a bracket. That just says x is less than or equal to negative 3. Okay, tons of stuff here. Make sure you go over all the boxes, check them off, read section 2.5. Sorry I wasn't there in class, but that's how life goes. Okay, hope you guys are doing well. Bye.